Um, it was okay. Not my favorite.
Same. I feel like we're going past like what I understand into like just kind of do it, but there's like no basic like there's no reason behind
I
why
know
we're
I mostly just put stuff in Excel sheets now for
same,
this class and then read the answer, and I'd have no idea why.
right? That's exactly what I'm feeling about this right now.
Yeah.
So I guess we yeah. I feel what?
Oh, I just wanted to know what you were saying. I didn't hear you.
Oh, I was just, oh, can you hear me now?
Yeah.
Okay, cool. All right. So I guess we should start on the preparation homework.
Mm-hmm.
For the first one, what are the null and alternative hypotheses for the ANOVA? And for one, it's the null is all the means are equal, and the alternative is one or more of the means differs from the others.
Mm-hmm.
So I think that's always going to be the case. Like,
yeah.
yeah.
Unless they tell us specifically what they're trying to do. Okay, for two, for one of the assumptions for ANOVA, what is the rule for examining the variance of each sample? And so if the largest variance is not 4 times of the smaller one, then they're equal. You can conclude that they're equal.
Yep. And then, what are the differences between the tests of hypothesis for ANOVA and other tests of hypothesis that we have covered to the point of this class? And I put that like we have to deal with variances in this one, and that this hypothesis test is like multiple like things.
More than one variable.
Yeah, there's more. There's more than one variable.
Uh-huh. That's basically what I had as well. And then for part two, ANOVA, according to William Butler Yeats, she is the Gaelic muse, for she gives inspiration to those she persecutes. The Gaelic poets die young, for she is restless and will not let them remain long on earth. One study designed to investigate this issue examined the age of death in writers from different cultures and genders. 3 characters or categories of writers examined were novelists, poets, and nonfiction writers. The ages of death for female writers in these categories from North America are given in this worksheet, I guess. You would like to determine if the mean age of death is different from any of the categories of writers and use a 0.05 significance level. And so design the study. And so what is the research question? And it's asking what is the mean age of death for the different categories of the writers. And then the null hypothesis is all the means are equal, and then alternative is one or more are different.
Cool. That's what I got. All right, collect the data. Describe the data collection procedures. And I put we don't know how the data was collected, so they didn't talk about it, but we do know that the data was taken from female writers in North America.
Mm-hmm.
So.
And that's describing the data as well. So this, okay, yeah. Describing the data, so it's just saying like the novelist had the number was 67, and then the mean was 71, I think is what I had.
Yeah, I have 71.448.
Okay, yeah, and standard deviation 13.052. And the poets just had 32 people that they had. And then the mean 63.188 and standard deviation of 17.20 or 297.
Mm-hmm.
And then nonfiction, they had 24 people, and then the mean was 76.875, and then the standard deviation was just 14.097.
Cool. I didn't know how to do the box plots on Excel, so I didn't even worry about it. I just did the other graph.
Yeah, I didn't figure out the box plot either.
Yeah. So for 4, make inferences. What type of hypothesis test is appropriate? And I put an ANOVA test.
Mm-hmm.
And what are the requirements for this test? The data are normally distributed within each group, and the variances are equal for each group. Are the requirements met for this test? And all my QQ plots looked pretty normal except for some outliers.
Mm-hmm.
And then for the variance test, the highest variance 2.29, not 29 or 2.9, 299.190 is less than 1 point, what? Oh my gosh, what is with this 1 point? 189.73 times 4. So, yes. Variances were good.
Yeah.
And then for the test statistic, I got 6.563.
That's what I got as well.
And then the degrees of freedom. Okay, this is where I got super confused. Because my answer was completely different from the answer sheet.
Uh-huh.
Was yours the same or what? Because I looked on the answer sheet and it was like 12,000 or something. Or maybe I was just reading the wrong one, but it just did not look right.
What did you get for that?
I got 122, but I might have also been reading the wrong thing.
I didn't get the right answer either, but I don't know what I did wrong.
And it didn't really tell you how to do it in the homework. It just said take it.
Yeah. And before we used to be able to calculate the degrees of freedom on our own, but now it's
not.
Now we just have to rely on the Excel sheet, which I don't like because I don't even know what the Excel sheet is doing. I have no idea.
Yeah, I have no idea. So if they ask us for any degrees of freedom questions, I'm just gonna be like, oh, no idea.
Maybe we can figure it out on the homework.
Ready? It's like, so the thing you gave me was wrong. I don't know how to do it other than that. So
yeah.
All right. So compute the p level, the p value. Well, wouldn't it be that? Oh, never mind. The p value and compare it to the alpha level. And I got 0.002, which is less than 0.05. So for making a decision, I put we are able to reject the null hypothesis. And then present your conclusion in the form of an English statement, because this isn't English. There is sufficient evidence to support that at least one of the mean ages of death of female writers is different from the rest of the mean death ages of the other categories of writers.
And then for take action, I wasn't really sure what they wanted.
Yeah.
I didn't really know what to say besides what they already told us or besides what the English statement was.
Yeah.
What is the significance that you can conclude from this? So I just kind of had the same thing from H.
For 5, I said, don't be a poet if you're going into writing because you'll die sooner, apparently.
Yeah.
But, yeah. So.
I feel like that's not really logical, though.
Right? It's like, well, maybe poets, like Edgar Allan Poe, he was a poet and he had kind of a crazy life, but he also was a severe alcoholic, and most poets, are severe alcoholics. So I think there's, other factors.
Probably. It probably just doesn't depend on, it's not because they wrote poems.
Correlation does not equal causation. But that's just, it's funny that they were like, that's a good study. Let's do that. All right. Okie dokie. Let's do this quiz. You ready for it?
Yeah. Just need to get Excel open, actually.
gonna need more data sets.
All right. Mine's opening right now. Whoa.
You okay?
Yeah. Oops. Do redo that.
All right. It's an 18 questioner.
Copy. Ah.
I love how the first two are always the same.
Mm-hmm. Ah, oops. Okay, I have it all copied in there now.
Perfect. Oh, are you are you on the data test already?
Oh, I was just putting it in right away. I don't know. I always open it right
Smart.
when. Okay, sorry.
I see
So,
what you did there.
yeah.
Okay. So for number 3, in an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different from the others. I put true.
True. Yeah.
Yeah.
What requirements need to be checked when performing an ANOVA hypothesis test? And so it needs to be normally distributed,
Mm-hmm.
and the variances are equal in each group.
I don't know if they're equal.
Yeah, it doesn't have to be because that other one didn't have equal numbers. But
Yeah, it just have to be like the largest one just has to be less than the smallest one times 4.
oh, yes. Wait, and so the sample means are all positive? Do they have to be positive?
I don't know. I don't ever think that's been a requirement.
We haven't had any negatives, but I feel like it
Yeah,
could be depending on what you're testing.
Yeah, so I think
But
maybe
it says mark all that apply, which makes me feel like there's more than one.
maybe they're testing us.
Maybe. We always have a second chance.
Right? Yeah, I'm gonna just go with the 1 because I don't think we've ever had there's never been. Well, for the ANOVA test, it's just that too. Like the data has to be normally distributed and the variances
Mm-hmm.
to be so. To check if each group is normally distributed, do the following, and it's construct a QQ plot.
Mm-hmm.
Okay.
And then we assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than the largest sample mean.
So maybe
So the
that
second one.
So maybe that does mean the variances are equal in each group. But, well, that's so confusing.
I thought it said, like in the homework, it said the largest one is 4 times the smallest one.
Oh, yeah. But the question is, we assume the variance in each group is the same if the following happens?
Oh.
So I'm wondering if that means the variances are equal.
Are the same? True. That logically doesn't make sense in my head, though.
It doesn't make sense either, but like, why would
maybe it says it right there.
Yeah, so maybe we should put it. I don't know.
Maybe. I'll try it.
Okay.
We can see if that's right.
Okay. All right. So in an ANOVA hypothesis test, an ANOVA hypothesis test is equivalent to conducting 2 independent sample t-tests between every pair of samples. There are 3 tests. There are 3 pairs: 1 to 2, 1 to 3, 2 to 3. How many pairs are there when there are 4 samples? Wouldn't there just be 4?
4? Yeah. 1 to 2. 1 to 3. Wait. I think there might be an extra one because it'd be 1 to 2, 1 to 3, 2 to 3, or like 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, and then 3 to 4. So there's 6.
Yeah. All right, soccer shoes.
Okay. The data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A through E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from the target, and that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. What's the minimum smallest variance?
All right. I should have just copied and pasted it like you did before. It's a good idea.
Mm-hmm.
For the next time. Holy cow. That's a lot of data.
Yeah, there's a lot of it.
You know if Abby has heard from the other group? Because I know he said that we need to start working on our proposals for this week. So
I'm not sure if she's heard yet.
No, what proposals? Oh my gosh, what proposals? Okay. So, what was your smallest variance?
I have 27.358.
I
Wait, 27.208 actually. There's one smaller.
My smallest was 25.912 for variable 5.
Oh, really? My
Yeah.
variable 5 is 31.011.
From E to socks. Let me try it. Oh, yep. Apparently I didn't have all of it. What is going on? Same number of data. Okay. Okay, so yeah.
All have the same amount in each group.
Okay. So that was question 8, was the minimum variance.
Did you get Did you have 27.208?
Wait, yep.
Mm-hmm. Okay. What's the largest one now?
56.262.
Oops. Okay, the test for equal variance is satisfied with these data.
I'm sure. Because
yes.
I think
That's not 4 times bigger.
Yeah.
Oops.
Oh, I have to open more Excel now.
Construct a QQ plot for each of the 6 samples. Ah.
Okay, quantitative descriptive. Ooh.
Oh, there's so many of them.
I know, this is going to take forever. Okay. I'm starting with 6.
Okay. Do you want me to do the first 3 and you can do the
Yeah, that'll work.
last 3?
So 6 is pretty normal, except there's like at the first, like there's some that just go way off. So I don't know what. Okay, that one's pretty normal.
Oh, the first one is not normal at all.
Really?
It's all over the place, yeah.
Okay.
So maybe we don't need to do the rest of them.
Well, I did, so. Oh, wait, did you sort it? Because the first one is approximately normal if you sort it.
Oh, yeah, I forgot to sort it. Oops.
Oh, okay.
Oh, wrong way. Okay.
Yeah,
that's normal, actually.
Did you have like one more than all the others? Because for variable 4, I have 43. So
A, B, C. So the D one, I have all the same. Like,
they're all the same. Okay, I think then I added something because that changes my answer for one of them then. Because now the largest is 53.1.
I had 53.158 for the largest.
What is it then? So all of them, like they're approximate, like they're pretty normal, but they're not like super normal. Like there's some that have like some weird, but they all kind of follow the straight line.
Yeah, for the most part.
I'd say they're approximately normal.
Yeah, besides a couple outliers.
Good word.
To observe.
Then remove the SOX data. Oh, cool.
SOX was the last one, right? Why does it never let me do that? It never lets me delete all of the numbers at once.
And every time, like, if you do delete all, like, I'm pretty sure it deletes, like, the equation out.
I think, yeah. Okay.
What did you get?
The question, it's asking for what is the p-value?
Yeah, when you remove
when you remove the SOX. I have 0.309.
Same. Okay. Is it to the left or the right of the F statistic? I think it's to the right. Is it? I don't know.
F number line. Did you say left?
Yeah, I think it's to the left because it's smaller.
I think so. Yeah, I think so too.
And
Because if you had it like on a number line,
yeah.
it would be on the left.
All right. Hot dog nutrition. Woo. Yummy. This is a great hot dogs. Nutritious. That's what I think of.
Super nutritious.
So nutritious.
Oh, good. There's only 2.
Oh.
Oh, never mind. But
Just kidding. What the heck? This makes no sense. Are we doing calories or sodium?
I don't know. Maybe the question asks.
The calories first. There we go.
Okay.
I like how it goes from beef to meat because beef isn't meat.
Yeah. Meats other
Maybe
than
that's
beef.
like mystery meat. That's
probably.
Poultry.
See, I don't like having to delete everything. I'm just gonna press undo. What happened? There we go.
Okay. So, oh, QQ plots. Cool. Yay. At least it's not like as many.
Yeah.
I'm getting really good at my Excel usage though.
Mm-hmm.
Like, I'm figuring out computer stuff.
Yeah.
Oh, number 3 is kind of funky. Poultry. Their QQ plot.
I haven't gotten to that one yet.
They're all kind of funky. Like they curve like in certain areas. So it's kind of weird. I don't even know.
Yeah.
Well, the variance is
It's kind of off, but
equal.
mm-hmm. Dogs and comparative variance.
I think, I don't know, for your QQ plots, what did you get?
I had like they were kind of normal. Like I think if there was more data and it was just that much off, it would be normal. But there is not very much.
Yeah.
Like maybe it's not totally accurate.
Yeah, because like the variances are equal, and there's the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal because they are, but the data is not normal. So
That's one of the options.
yeah, that's one of the questions. That's one of the answers.
I would say that one. I think.
All right, let's go for it.
Okay, so the assumptions have not been met.
Yeah. I don't know. I didn't like how the QQ plots look.
Oops, wrong one.
Shady.
So you said the assumptions have not been met or it is not safe to assume that each comes from a normally distributed population, but you can assume that the variances are equal. Yeah.
Okay.
Okay, run an ANOVA test to determine if the mean number of calories. Is that the one we're doing already?
Yeah. The degrees of freedom are 2 and 51. Yep.
2 and 51.
So
We
I
have
think
0.000.
so because the p-value is less than the significant value, then the level of significance.
We have
I think we have sufficient evidence to claim that at least one type of the hot dog types has a different mean number of calorie than another type.
yeah. At least one of them. Oh, now we have to do the sodium.
Woo! Because I'm hot dogs.
The first one's pretty close. It has a few that are off, though.
I haven't even inputted them into the ANOVA yet. So, 1 second.
Ah, that's so loud.
Oh. Thomas, you're okay.
Pretty normal.
What's up? Mm-hmm.
Oof. The last one's not really.
The last one is not normal at all.
Yeah.
Yeah, show me. Show me where you need a kissing. Okay. I'm sorry. Okay, I'll be done in a second. I know. Okay. The variances. I'm gonna take a look at those real quick. Oh, whoa. I got a lot. Dang, beef hot dogs have like insane amounts of sodium.
Oh, no.
So the smallest variance.
Why is it doing that?
Well, the variances are still not equal at all. Nope.
Yeah.
So I don't think any of that is equal.
Yeah, the assumptions have not been met. It is not safe to assume each group comes from room. You cannot assume that the variances are equal. I think it's that one.
Yeah. Despite the possible problem. Oh, hey, there you go.
Oh, yeah. Poultry.
I love how they're like, oh, the conditions are met, but still do it.
Yeah.
The p-value. What did you get for your p-value?
I need to re-put the data in.
Okay.
And, oh, I also did not have all these deleted last time. Okay.
Wait a second. Okay, so actually the smallest variance, the variances are equal. Because if you do the largest is 10,000, but if you do 7,000 times 4, you get 28,000. So.
Okay. Oh, why is it?
So I think the. Asher. Yeah, you got all of that stuff out again. Thank you. Can you go put it back in? Oh, okay. Okay. My p-value was
My p-value was 0.179.
That's fine.
And then, did we have to change the variance one? Because I have.
So the variances are equal.
Yeah.
Because I didn't copy and paste the correct data.
Yeah.
Thank you having.
So then, but we can't assume they're equal for that last one. Oops, and I forgot what I said. 0.179.
So for the hypothesis test, I think we have sufficient evidence to claim that all 3 hot dog types have the same mean sodium level. Oh. Is it same or different? Same.
But it's less. The p-value is less. Yeah.
So.
Yeah, I think so. Oh, that's it.
Cool. Let's see how we did. There's some I'm kind of a little shaky on. So.
I know.
Okay, so we missed
it was right.
Statistic. And wait, why is that last one wrong?
Oh, wait, I also got 15 wrong. Oh, that 15 wrong?
Yeah. I got I got 15 right.
Oh, wait, which one did you put then?
So for 13, I got 13 and 14 wrong.
Oh, me too. So the assumptions, maybe they are. Maybe the Q tests weren't that far off, I guess.
And then we got 18 wrong.
Yeah, I'm gonna grab my notes quick.
Okay, so we got our p-value right, so we do not have sufficient evidence to reject the claim that the mean. Because the null hypothesis is
that they're all equal.
And we failed to reject the null. So I don't know why that's wrong.
No, wait, we didn't fail to reject it. So when the p-value is less, we're supposed to reject it.
We rejected it.
So
wait, no, we failed to reject the alternative because the p-value is larger than the
level. Oh, it is larger.
Yeah, so we failed to reject the null.
Yes.
I mean, yeah. So
we have. We do not have. We have. What?
See, yeah, I'm super confused by this one.
Maybe our data is wrong.
Well, no, our p-value is right. That's what it, like, it's confusing. So,
Yeah.
I don't know.
This always happens to me on the homework, and then I spend so long trying to figure it out.
Like, I'm pretty sure 14 is, and 13 we go right. I don't know why we go right, but okay.
Yeah.
I don't know. Do you think it's we don't have sufficient? Because I don't think all three types have different mean levels, and I don't think we have sufficient evidence to claim that at least one of the hot dog types has a different mean, because we failed to reject the null, so.
Yeah, maybe I'm going to go back to the original thing and see if it said anything.
Okay.
Where is that, though?
I'm gonna try,
And that, okay, Renee. Calories. It doesn't really say anything.
yeah. So I'm retaking it. Let's see.
I wish these tests would just keep the ones you got right entered in.
That would be super nice. Also, it would be nice if my computer worked. Okay. Okay, so question 13. It's right, not left.
Yeah. And then for 14, did you have?
I'm just going to put the assumptions have been met.
Yeah.
All right, and then for 18, what are you going to do?
Oh, I don't know because
I feel like our right answer is right, but
yeah,
it's not.
We have oh wait. Because we do not have sufficient evidence to reject. Wait, that means you would accept. So that one.
Yeah, see, I don't understand any of these.
So it's not that one. We have
Definitely
sufficient,
not 3.
not the third one.
No, because we have sufficient evidence to claim that all 3 hot dog types have a different mean sodium level, and we've never done that.
Yeah. And it's not the second one either because we're not rejecting. Wait.
Wait, we do not have sufficient evidence to reject the claim that all. Well, no, we have Okay, I hate all the double negatives.
I know. We have sufficient evidence to claim that all 3. So we failed to reject.
No, but this is
which is they equal, and this is saying
we
we
can't.
can't, so we accept the claim that all 3 have the same. Well, maybe it's that one because we know.
Make any sense.
Yeah, I try the second one.
Okay, I'm gonna save and submit. I get this. At least I know I got one of them right. That I got wrong. Well, I haven't missed any yet. Yep, that was it.
Oh,
you got
perfect. That was confusing, though.
Yeah, it was. I did not like that. All right. Well, I will post this then.
All right. Awesome.
How to do that. See you Wednesday.
Wednesday. Yep.
For no more hypothesis tests.
Yeah. All right. See ya.
Yeah. Bye.